Welcome, Algebra 2 students. In this lesson, we're going to be reviewing and looking over factoring quadratics. We'll first start with the first type of factoring that you can see, which is factoring out the most common factor that is in each term, also known as GCF factoring. You want to make sure that this is always the first thing you look for and the first thing that you do with any of the problems we're going to do in this lesson. So first, let's take a look at number one here. Number one, I see 6m plus 3. So what I'm looking for is I'm looking for the biggest thing that I can divide into both 6 and 3. So what is that number? Did you say 3? Because if you did, that is 100% correct. So here's what I'm going to do. I'm going to think about this now. And I'm going to think about, okay, if I was able to divide a 3 out of both of those terms, and I was going to kind of do the distributive property backwards, what times 3 would give me 6m? What times 3 would give me 6m? Well, that would be 2m, right? 3 times 2m is 6m. I'll repeat that same process again and say 3 times what would give me positive 3. You got it. It's positive 1. So I've pulled out a GCF and have written the expression as 3 times the quantity of 2m plus 1. If you wanted to check yourself, all you'd have to do is you'd have to just distribute that 3 back through to see if you would end up back with your original problem. Let's do the same thing with number 2. So we're going to look at each one of these terms and say, what is the biggest number that I can divide into 2x squared, negative 4x, and 8? And you're right, the answer is 2. So I'm going to factor out a 2. And what am I left with? Well, let's see here. Thinking about it in that reverse distributive way, 2 times what would give me x squared? Well, just x squared. 2 times what would give me negative 4x? Negative 2x. And 2 times what would give me 8? You got it, positive 4. This is the final answer. And if you wanted to, you could just, again, distribute through and see if you came up with the original problem again. Why don't you give it a try with these two problems? So pause the video right now and try it with number 3 and 4 to see if you can come up with the GCF factored form. All right, with number 3, what can you divide into both of those terms? You got it. It was 5 and an x. Did you catch the x? It's not just a number sometimes. Sometimes you also have to figure out what that variable is that you can divide out as well. So it's here. That would give me 3 here. And then plus what times 5x will give me 25x squared? 5x. Now, the only thing that I may do is I may switch that order inside the parentheses to kind of put it in that order that we're used to seeing things. Let me fix that 3. There we go. Better. Okay, what about with number 4? What can I divide into negative 3r squared and negative 27r? Do you see how that negative's in both of those problems? So I'm going to go ahead and pull out that negative as well when I factor. So I'll make it negative 3 and then r. And then I get, let's see here, negative 3r times r, and then what would that, plus 9. We end up with a final factored form there. Now we're going to get into factoring some trinomials. Okay, and we got to do these a little bit differently because what we're trying to do is we're trying to ultimately go from 3 terms to make it something times something else. And it's normally a binomial times another binomial. So we have to figure out when we did foiling backwards, what would I end up with if my answer was x squared plus 8x plus 15? What did I start with? That's tricky. So in order to do this best, what I do is I like to set up this little x. And what I like to do up here at the top is I like to put in the 15. I get that 15 from right there, that positive 15 from right there. And then I take and I put this 8x, and that 8x goes down here in the bottom, just the 8. And what I'm looking for is I'm looking for the pair of numbers that multiplies together to give me 15, but adds together to give me 8. Now, if you don't know, what you can always do is you can always write out all of the numbers that multiply together to give you 15. So like 1 and 15, 2 doesn't work, but 3 and 5 does. And if I look at this list, and this is a complete list, I really can't do anything else there. I mean, I guess you could include negative 1 and negative 15 and negative 3 and negative 5, but I don't think you'd have to for this particular problem. Anyway, I'm looking for the pair of numbers that multiplies together to give me 15, but adds together to give me 8. And right there's my answer, 3 and 5. So what's my answer? My final answer will be, if I use that, it will be x plus 3 times x plus 5. And it's really just using these two numbers that I came up with right here and putting them into the binomial. Now, if you want to check yourself, you can always check yourself. So we can go over here and I can check my answer. Let me just check it real quick. So x plus 3 times x plus 5. Let's check it. So we'll FOIL. We'll do firsts. We'll do my outsides. We'll do my insides. And we'll do the lasts. And when I do that, let's see here. Those are the only terms I have to combine. So I get 8x squared plus 8x plus 15. And I came up with the right answer. So that checks out. That's the right answer. So that process works really nicely. Now, you can just kind of maybe do this in your head. You might get really good where you can do this in your head, but I want to give you a process that will always work. So I like to set up this x. And again, that 30 will go in the top, and that negative 11 will go down here on the bottom. So I'm looking for the pair of numbers that multiplies together to give me 30, but adds together to give me negative 11. So when in doubt, we can always write it out. Let's see here. We got 1 and 30. We got 2 and 15. We have 3 and 10. 4 doesn't work, but 5 does. So 5 and 6. That would be my list unless I included my negatives, which I should in this case, and I'll show you why here in a second. So let me finish writing out my list here. See, I need the numbers that add together to give me negative 11. And 5 plus 6, which is right here, adds together to give me positive 11. But I need the negative signs, negative 5 and negative 6, to add together to give me negative 11. So those are my two values right there, negative 5 and negative 6. And therefore, when I factor this down, what do I get? I get x minus 5 times x minus 6. That would be my final answer. So I have a lot of problems here that I'd like you to try. The process isn't difficult, but sometimes it can take you a while to figure out what that pair of numbers is. It's kind of like a game to me, so I play that little X game every single time to try to figure out my values. So here's 6 problems, and I want you to pause the video right now, and I want you to try these out. Okay, so pause the video right now. We will go over these 6 problems. I'll show you how to do it, but go ahead right now, pause the video. Try them out. All right, so here's the first 2. Let's start with A, x squared minus 8x minus 9. So first I'm going to set up my x. Next, I'm going to create a list of all the numbers that multiply together to give me negative 9. What are the numbers that multiply together to give me negative 9? Then I'll figure out the pair of numbers that adds together to give me negative 8. That would be 1 and negative 9. So my factored answer would be x plus 1 times x minus 9. Let's go over here to B, x squared plus 3x minus 18. I'll set up my x. I'll write out all of the numbers that multiply together to give me negative 18. And I'm looking for the pair of numbers that multiplies together to give me negative 18 and adds together to give me positive 3. That's negative 3 and positive 6. So my answer is x minus 3 times x plus 6. Let's take a look at problems C and D. I'm simply going to reveal my work for you for these problems, and then you can check yourself after I'm done showing you the work. You'll see for letter C, the answer is x plus 3 times x plus 18. And for D, the answer is x minus 4 times x minus 9. Note here, I knew that 4 times 9 gave me 36, and 4 plus 9 was positive 13. Well, if it's positive 13 and I need the negative, and negative 4 times negative 9 gives me positive 36 and adds together to give me negative 13. Now for E and F. Here is the work for E. You'll see that the answer is x plus 5 times x minus 8. And I didn't finish my list. Once I found my answer, I stopped my list. The same thing I did over here with F. Right, I got here and I said 2 times negative 9 gives me negative 18, but when I add those together, I got negative 7. I knew I needed positive 7. So if I made it negative 2 times positive 9, that still gives me negative 18, but the sum here is positive 7. And I didn't bother finishing my list because once I find my answer, I can be done the problem. Moving on. There is a special rule that can kind of give us a shortcut to coming up with our answer. Now, if you did number 7 here, the way we had just done it in the previous problem, you could still do it the exact same way. You could still look for the pair of numbers that multiplies together to give me negative 64 right here. But you'll notice that there's no value for b, so that would be 0. So we'd be looking for the pair of numbers that multiplies together to give me negative 64 and adds together to give me 0. Let me make that list right now. So the number I'm looking for is the pair of numbers that multiplies together to give me negative 64, but adds together to give me 0. And it is positive 8 and negative 8. So my answer would be x minus 8 times x plus 8. Now that's all great. We could totally do it this way if we wanted to. Or let's take a look at it a different way. If we recognize it based upon our shortcut rule, the difference of two perfect squares. So if I see this as a perfect square minus another perfect square, and x squared, well, yeah, that's a perfect square. I'm just going to write it like this just so you can see it. That's the quantity of x squared. And then minus another perfect square. Well, 64. Okay, hold on. Let's back up for a second. Perfect squares. Perfect squares. You should remember perfect squares. And if you can't remember perfect squares, simply develop your list. So your list is 1 squared and 2 squared and 3 squared and 4 squared and so on and so forth. So that list looks a little something like this. 1, 4. 3 squared is 9. 4 squared is 16. 25. 36, that's 6 squared. 7 squared would be 49. 8 squared, 8 squared is 64. 9 squared is 81. 10 squared is 100, and we could keep going. That's a really nice list of numbers for you to just be able to recall off the top of your head, because those numbers are really special. That'll allow you to see this 64 not as a 64, but instead as 8 squared. And if you can see it as x squared minus 8 squared, dramatic pause was intentional there, you can rewrite your answer using my rule, a minus b times a plus b. So x minus 8 times x plus 8. Now that got us the same answer as we did last time. It's just a matter of what you see. But when you look at number 8, we're not really sure exactly how to do these types of problems yet. But if you recognize 16 as being a perfect square, and if you can recognize that as being 4 and then x squared minus 81, 9 squared, you can very quickly write your final answer as 4x minus 9 times 4x plus 9. But you have to recognize it as perfect squares in order for that to work for you. So here are 6 problems for you to practice on your own. Now, I'm telling you that these are the difference of two perfect squares in all 6 cases. So it's going to be up to you to figure out what they are. I will tell you and give you a hint here. For one of these problems, maybe more than one, you have to do something before you see the difference of two perfect squares. But that's the only hint that I'm going to give you. So pause the video right now and give these 6 problems a try. Go ahead, pause the video. All right, let's look at A and B. For A, x squared minus 144. Did you see that as x squared minus, a perfect square, 12 squared? If you did, it was really easy for you to write the answer as x minus 12 times x plus 12. What about B, 169? That's 13 squared minus x squared. So you could rewrite this as 13 minus x times 13 plus x. Watch the order, it absolutely matters here. For C, this is 9x squared minus 16, so you should see 3x squared minus 4 squared. That'll give you 3x minus 4 times 3x plus 4. For number D, 121, that's 11x squared minus 7 squared. So you should get 11x minus 7 times 11x plus 7. For letter E, 50, 200. They're not perfect squares. What's up with this one? This is the hint that I needed to tell you about. This is that special one that I was speaking about at the beginning. In order to factor this problem, you first should always look for the GCF, and I bet you forgot about that here. Look for the GCF. What can I divide into both 50 and 200? What can I divide into both of those numbers? Did you say 50? Because if you did, you're right. I can divide this by 50. I get 50 times the quantity of x squared minus 4. Now, I'm not done yet, because inside this parenthesis, that is actually the difference of two perfect squares. You should see x squared minus 2 squared. And if you did, then this can be factored further. You can write it as x minus 2 times x plus 2. Now, folks, don't forget, you still have the 50 in front the whole way down. So it's just this second parenthesis that you're actually factoring out things more in. Okay, let's go on to number f. And number f, we got the same thing. Look at this. 4x squared minus 64, we can factor out a 4. So we should totally do that first. And then, if you look here inside the parentheses, you got this 4. But what do I have left over? I have an x squared minus a 4 squared. And then I'm going to factor out that inside parentheses. So I'll get the answer of 4 times, so here that would be x minus 4 times x plus 4. And that would be my final answer. Folks, that's the 3 different types of factoring I wanted to talk to you about in this video. It's time to go practice this concept a little bit. So time to work it out then. And if you have any questions, please always let me know.